Good evening, everyone, and welcome to tonight's community conversation, Urban Ecology, Bringing New Lens on the Sea. My name is Sara Benson, and I use the pronouns she and her. I am an education associate in the Forums and National Collaborations Department at the Museum of Science in Boston. I'll be serving as your moderator for tonight's discussion, which we are facilitating in connection with World Oceans Day, which is coordinated globally by the United Nations to celebrate together the beauty, the wealth, and the promise of the oceans. If you're watching on Facebook, thank you so much for watching and being a part of this program, but please know that we cannot see your questions and comments from that platform. If you are on Zoom, just press the Q&A button at the bottom of your screen to ask questions at any point during tonight's program. If you would like to see captions, you can click on Close Captions button at the bottom of your screen and select Show Captions. We want to start tonight by acknowledging and taking responsibility for our part in the systemic racial injustice in our country. We know that this group lacks racial diversity, and it is a clear example that access to scientific and environmental disciplines are inequitable. We have a lot of work to do still within the STEM community, and we have been continuously thinking about opportunities that we have as a museum, as our institutions, and as individuals to bring about positive change. We are really excited tonight to have you joining us this program with a team of researchers working together to connect the arts, psychology, marine biology, and urban planning to get people thinking about the ocean, making personal connections to it, and being a part of it. Most importantly tonight, we want your input to understand how to make this relevant to you. So here's the format for our program tonight, which should last for a little less than 90 minutes. You'll hear presentations from the CLEAR Lab, who are working on how to connect people around the world to the oceans. You'll hear about research from the field of psychology that helps us to understand and connect us emotionally and cognitively to the oceans. Then you'll hear about ways that art and urban planning can help to illuminate and share ecosystems under the water through visualizations. Finally, we'll consider ways to build connections to ecosystems through storytelling and emotional engagement. So now I would like to introduce our first panel. Our first panelist tonight is John Coley, who is an associate professor of psychology at Northeastern University. John and his lab study a host of interrelated questions, including connections between the environment, understanding, and environmental behavior. Brian Helmuth is a professor of marine and environmental science and public policy and urban affairs at Northeastern University. Brian's research and teaching focus on predicting the likely ecological impacts of climate change on ecosystems. Frances Choi is the senior lab manager at the Helmuth Lab at the Marine Science Center in Nahant. And Harley Hayes is a fourth year at Northeastern University studying environmental science with a concentration in marine biology. She is currently working with Brian and Frances in the Helmuth Lab. Before our panelists begin, we'll be asking some questions to connect the CLEAR Lab's research as this event goes on. So we are going to start with a couple of polls using the Zoom feature, using Zoom. So the poll should launch right now. The first question is, to what extent do you think the ocean impacts people? That poll should pop up right on your screen in Zoom. Feel free to answer that, and then we will share the results with all of you. All right, so now we will share results out. So it looks like most people say 7, to the great extent that the ocean impacts people. All right, so now we have a second poll. This is, to what extent do you think people impact the ocean? You'll go from 1, not at all, to 7, to a great extent. It should also pop up on your screen in Zoom, and feel free to vote. All right, looks like most people have voted. So 78% of us believe to a great extent that people impact the ocean. So thank you all for using those polls, and we'll be doing some more polls throughout the program. But for right now, I would like to invite John Coley to start us off with the presentations.
Thank you, Sarah. I'm really excited to be here talking to you today. As a cognitive scientist, I have been studying how people organize and use their knowledge about the world for 30 years or so. And so I want to make it clear that I don't actually study the ocean. Rather, I study how people think about the ocean. And the point I want to make today is that to influence how people behave toward the natural world, we need to understand how people think about the natural world. So you just answered two different questions. We asked you, to what extent do you think people impact the ocean? And to what extent do you think the ocean impacts people? And what's critical about these questions is it's asking about the reciprocity between human beings and an important natural system. Your responses were relatively high for both of those things, suggesting that you as an audience see this reciprocal relationship. People impact the ocean and the ocean impacts people. However, I have to say you're a pretty select audience. Typically, when we ask these questions to research participants, we find a pattern that looks more like this. We find that people overestimate or show this asymmetrical pattern where they think people have a huge impact on the natural world, but people don't really depend on the natural world. This is a general pattern of thinking that we refer to as human exceptionalism. And human exceptionalism is the belief that humans are discontinuous from the rest of the natural world, that humans are biologically unique and not really subject to natural laws or processes. So if you were to represent what a human exceptionalist view of the world looks like, it might look like something like this, with humans on top and everything else arrayed below us. When in reality, we know that the real picture looks more like this, with all living things being a web of life. And in case you can't tell, you are there. One species among many. So in the work we do, we study this idea of human exceptionalism and its impact on environmental thinking. In one recent study done with this team, we showed that people recruit exceptionalist thinking to reason about human impact on urban waterways. So to do this, we told people a story about a fictitious urban waterway, a river running through a city. And we asked them a series of questions, like the questions we asked you, among many others. So to what extent do you think the river in the story impacts the people who live in the city? And to what extent do you think that the behaviors of the people in the city impact the river? People responded to each of these questions on a scale of 0 to 100, slightly larger than the scale you responded to, but the same idea. And what we found was that people showed an asymmetrical understanding. So people thought that people had a larger impact on the river than the river had on people. So rather than showing a sort of symmetric cyclical relationship, you see this asymmetric relationship. This is a typical human exceptionalist view. We also, in the same study, found that exceptionalism has real downstream consequences. So people who were higher in exceptionalism were willing to local, state, and federal tax dollars in river restoration. They were less willing to volunteer time for river restoration. They were less likely to think that the river was worth restoring. They were less willing to donate money to support restoration. And finally, they were less likely to believe that people are ecologically connected to the river. In other work done by Nicole Betts in my lab, she has shown that a similar situation exists with climate change. So people are very willing to admit that humans have a large part in causing climate change, but don't really think that humans are climate change. There is hope, however. What Nicole has shown is that if you ask people to draw what's called a concept map, where they're connecting their ideas about climate change and about people, so kind of forced to actually explicitly draw out how these different concepts are related to each other, we find that people employ not only humans as causes to climate change, but also show that they understand that people can be affected by climate change. So the idea is, by pointing out, or by reminding people really of the fact that humans occupy part of this larger system, people go from seeing climate change in an exceptionalist way to understanding that the influences go both ways. So the points that I want you to take home with you today are to influence how people behave about the natural world. We need to understand how people think about the natural world. We need to know cognitively where people are coming from. Human exceptionalism is a common way for people to think about the natural world. Human exceptionalism, moreover, is associated with negative attitudes towards environmental stewardship. But finally, by increasing ecological connectedness, we can decrease human exceptionalism. And the rest of my colleagues talking to you today are going to talk about different approaches to increasing that kind of connectedness. So at this point, it's my great pleasure to introduce Brian Helmuth and Francis Choi.
Great, thank you, John. Give me 1 second to get my slides up there. All right, so I've been a marine biologist for 30 years now, and for much of that time, I've been what you might call a reluctant climate scientist. Like so many others in my field, I never set out to be a climate scientist and to study the biological impacts of climate change. Instead, like others in my profession, over and over again, I would go to study sites and see pictures like this, where we would show up on a coral reef. It would look perfectly healthy, as you see on the left. You go back a couple months later, and it looks like a ghost town. Barren bleached skeletons with a bunch of confused fish swimming around. A little bit later, these bleached corals would become rubble, a state that can last in for decades, covered with oozing algae. And marine scientists like me have seen examples like this all too often, and we have a pretty good handle on the physical causes. We know that increased greenhouse gases in our atmosphere lead to warmer temperatures. They lead to more acidic ocean waters, higher sea levels, and more extreme storm events. And at their core, the physics of why this is occurring are pretty simple. In fact, the scientific community has known about the potential for increasing levels of carbon dioxide and other greenhouse gases to trap heat since the mid-1800s. When a scientist named Eunice Foote did a series of really elegant experiments combined with calculations of the consequences of higher atmospheric levels of CO2 to planetary temperatures. Sadly, as has happened far too often, credit for the discovery was given to a white male named John Tyndall, who came along several years after Foote and essentially repeated what she had already shown. So today in the scientific community, we're long past the point of wondering what is causing climate change. We know what causes it. Instead, as biologists especially, we focus on the magnitude of forecasted changes, where they're most likely to occur, where they're likely to have the most severe impacts, and what we can do about it. So work in my lab focuses on a field called ecological forecasting. That's determining which ecosystems are most vulnerable as a function of their exposure, their sensitivity to that exposure, and their ability to adaptively respond to those rapid changes. And the same framework can be used to study human communities. And perhaps not surprisingly, we find that the most vulnerable people and populations are not necessarily those with the greatest exposure, but those who are the most sensitive and have the fewest options to adapt to climate change, which often equates to communities of color and people who are economically vulnerable. So the challenge of climate change to a climate scientist like me is thus to use best available science to predict where impacts are most likely to occur, what ecosystems and human communities are most vulnerable to those exposures, and to develop novel strategies to help reduce that vulnerability. And the way we do this is, as you heard from John, not to view humans as somehow separate from nature, but rather to view human societies as part of a coupled human natural system where we impact our surrounding environment through our choices and actions, but then those ecosystems in turn affect us. So for example, as we continue to pollute the oceans, this in turn has significant impacts on human well-being through things like our marine food supply. More often than not, and this is very humbling as a biologist, as a physical scientist like myself, we find that the physical science is often the easiest part. And in most cases, we actually have a pretty good understanding of what the vulnerabilities are, what causes them. The difficult part is how we implement solutions, which in turn depends on people's willingness to enact change. Much of the difficulty then comes about because of human perception and what we perceive as normal. So by definition, global climate change is a worldwide phenomenon, but it plays out very differently across the planet due to the movement of heat and water. So we can have one part of the planet experiencing extreme drought, while at the same time, we can have flooding occurring in other parts of the world. So in other words, how we experience weather at a very local scale makes it really tough for us to see the bigger picture posed by climate change at a planetary scale. Changes over time are also difficult to detect, and our sense of what is normal is strongly driven by recent experience and a phenomenon we call shifting baselines. So already Zoom calls like this are starting to feel normal, even though a couple months ago we might have been meeting in person. And this holds true for all aspects of our lives. So unless we have data that we can track these long-term changes, data that we trust and believe in, most of our decisions are going to be based on a shifting norm that may have little to do with reality. So for example, if I showed this picture to any recreational fisher, they'd probably say this is a pretty good catch. In fact, I'd be really happy if I came back with even just one of these fish after a night of fishing. But now we put that into the context of what was caught 10, 20, 50 years prior, and all of a sudden the size of the fish caught in 2007 doesn't seem so awe-inspiring when you compare that to these monster fish that were caught 50 years ago. So what it shows is that the baseline of what we think should be or what is normal has changed over time. And if we only believe what we could see with our own eyes, if we didn't trust in data, we would never know this. So as you can imagine, this has enormous consequences for how we perceive climate change, especially in a time when there's strong distrust of experts like myself and others who depend on data. And so for my group, that spurred this critical need to collaborate with the people on this team in new ways of sharing that we can see in our research. And so I'm going to pass it over to Francis Choi to tell you about new ways that we are developing to help communicate to people to help us solve these problems.
Thanks, Brian. So Brian introduced these high concept global ideas about the ecosystem and human impacts. But how do we actually take these concepts and translate it to the local level? So in our lab, our approach to science communication is to create a sense of place to our audience. This approach can only bridge global ideas to local communities, but it can also create civic dialogues, create a two-way conversation while learning from each other's perspective. One focus is the use of new virtual interactive tools to create dialogue. Here in the upper corner is a GigaPad virtual tour. Audience can explore, learn from the annotations, zoom in right to the small organisms, and even with the use of VR goggles, they can be completely immersed in these environments. When we create these virtual tools, not only do we create them to show them on the internet and as a way to communicate science, we also partner with local community groups, such as the Girls Inc. of Lynn here, to co-create these virtual tours. And what I mean is that the students are out there in these local environments as scientists, and they explore their backyards, they collect their data, they analyze their results, and more importantly, they tell their stories about their ecosystem. As researchers, we support them with the tools, the facts, and also extrapolate their ideas to how their local communities can reflect the global issues. The GigaPads live on the internet, so the students' experience can be brought back to their homes, and they can have their dialogues with their family and their friends on being stewards of the ocean. Another approach to science communication in the lab is through public forums. And we have collaborated with the Museums of Science on several excellent public forums on informing climate hazards, citizen science, and improving resiliency and decision-making. These forums are designed and use local narratives to create civic dialogues about climate hazard issues. As you can see in the bottom corner, the bottom left corner is showing a digital narrative of a town under a sea level rise risk. There's other various augmented reality content that we've inputted in these public forums as well. And you can see on the right, we have a bird's eye view of a scenario of sea level rise in Boston if no resiliency plans have been in place in Boston in 50 years. We also put augmented photographs of flooding areas and in iconic areas of the town. And these visualizations are built to aid participants to immerse in scenarios and have a two-way conversation with each other about the decisions they make. We bring these approaches to the CLEAR Lab to work with experts in various professions and explore the effectiveness of these approaches. So how to improve these by incorporating them in built-in urban landscapes or incorporate them in photographs. We also use psychology, as John showed, to understand how the science communication approach can impact human understanding. And with that, I'm going to turn back to Sara, and I think we're going to do a little bit of polls. Thank you, guys.
Thank you, Francis and Brian and John. So I just want to remind you quickly that if you would like to ask questions throughout this program, you can type those questions into the Q&A button, and we will be having questions at the end with all of our panelists. So don't forget to do that. But now I would like to ask Harley to come on, and we are going to launch some more polls.
Hi guys, and thanks Sarah. So at the start of the presentation, we took a couple of polls with you guys, and those questions were taken from a survey created by John, who we've heard from, to investigate how people view their local ecosystems and quantify their connectedness to the environment. So throughout this presentation, we're going to be asking you some of these questions taken from the survey, and at the end, we'll have a chance to show you some of those results that we've gathered from other participants in the past. So first off, we're going to ask you a question about your environmental stewardship. So to what extent do humans have a responsibility to protect their local coastlines? You guys can go and answer that one right now. Awesome. So it looks like a lot of you guys, 85%, answered to a great extent, and that's really great to see. And we're going to ask you one more question regarding your environmental stewardship, and that's, if you were a resident of a coastal city, how many hours would you be willing to spend on a Saturday to volunteer to clean up your local coastline? Great. So it looks like a lot of you guys had different answers for this one. The majority of you said half a day, about 51%, but the answers were a little bit different on this. Thank you guys so much for participating, and I'm going to hand it back over to Sara to introduce some more of our speakers.
Great, thank you all, and great polls. Thank you, Harley. Before we move on, we did have a question come in that I think can be answered quickly before we do some more Q&As at the end of this. But Sara, age 7, great name, says, how do we quantify cultural ecosystem services from the urban forests? So I don't know if Brian, John, or Francis would like to answer that.
I can take a stab at that. Sara, that is an absolutely fantastic question. Wow, you're really 7 years old. It's tricky, but you are absolutely right that the cultural ecosystem services are really, really important. And so there are lots of different ways we can do it. We can look at how much money people would spend. We can ask people with surveys, but what I think you're getting at is a really important question, that there's a lot we get from our environments that we don't even really recognize is coming from them. So that's an awesome question.
Yes, thank you. And continue to type your questions in. And like I said, we'll have time at the end to answer all of those questions. But for now, I would like to introduce our second panel. So our panelists are Keith Ellenbogen, who is a celebrated underwater photographer working with conservation-based organizations to showcase the visual complexity of underwater environments. Keith is an assistant professor of photography at SUNY Fashion Institute of Technology and a visiting artist at Massachusetts Institute of Technology Sea Grant. Dan Adams is the director of the School of Architecture at Northeastern University and a partner of an architectural design firm, Landing Studio, which focuses on the design of the public realm in industrial and infrastructural environments. Finn Payne is a third-year marine biology major at Northeast University and has worked in the core lab under John Coley for a year. So now I would like to introduce Keith as our first panelist. I think you're muted, Keith.
Can you hear me?
Yes, looks great.
Great. Thanks, Sara. And hello, everyone. So we are all connected by oceans and waves. And while we may look while they may look and sound similar, each wave is an expression of nature, connecting individuals, cities, countries, and continents. These are the big waves of Teahupo'o in Tahiti. On assignment within the Totoya Islands in Fiji, I spent hours waiting for the right light and cloud coverage to capture an image of a barrier reef in which the corals absorb the wave's energy to protect coastal communities from storms. My images focus on communicating complex environmental issues from perspectives that are hard to perceive and even harder to photograph. To capture these images, I was harnessed into, but sitting outside a helicopter. With the wind blowing, I would communicate with the pilot via a headset to position the helicopter to get just the right pitch, angle, and composition. Nature is one of the best artists. This is an abstracted view of a coral reef through the crystal clear blue waters. Just beneath the surface is a palette of vibrant, colorful corals, the symbol of a healthy ocean. to the Amazon, in which rivers are like oceans, shaping and sculpting the forest, creating fingers that form, quote unquote, mini islands. From an underwater perspective, river dolphins are tinted ruby red from the Amazon River. And in contrast, populations of endangered Atlantic bluefin tuna are tinted blue through the crystal clear waters within the Mediterranean Sea. To photograph this image, I spent 3 months in the Mediterranean Sea, searching for a rare moment in which tuna accelerated past my lens during their annual migration to reproduce. On the east coast of the United States, in Scituate Harbor serves as a marina for ocean voyages and fishermen. And Manhattan Island is one of the most densely populated islands in which skyscrapers dominate the landscape and nature is sculpted into urban parks. It's at this point, it's a great pleasure to introduce Dan Adams.
Hi, and I just want to make sure, can you see my screen?
Yes, if you can get into full screen for us.
Oh, great. Is that working now?
Yes, perfect.
Great, thanks. And I'm so happy to be here sharing this with you. So Keith's work provides new perspectives to see the environment in new ways. As an architect, I'm interested in how we build our context in ways that either make the environment more clear or more obscured. To pick up where Keith finished, this is the famous sanitary and topographical map of the city and island of New York, known as the Ville map, named after author Egbert Ville. This map overlays the historic rivers of Manhattan with the iron grid to show how the city uses the historic river systems as drainage for the city. Most cities were built near rivers for access to drinking water, food, transportation, and energy, but the flow of water across cities is used to simply clean the city of grit and grime, runoff, and sewage. Jumping to today, you see that the rivers disappear. But the flows of water from the city to sea aren't gone, they're obscured below ground. So a visitor or a resident has almost no way to observe how activities of the city directly connect to the ocean. The bleached corals or fish kills in the sea that Brian showed earlier are connected to our actions in the city, but much of the city's standard design practices obscure this relationship and disempowers people from engaging with this relationship. A quote I find inspiring and troubling on this subject is from author Deborah Kramer when she describes reactions or lack thereof to catastrophes in the ocean. Here she describes the common formation of dead zones in the Gulf of Mexico resulting from agricultural flushes from the Mississippi River. She says, if there were a terrestrial equivalent of the dead zone out in the open air, visible in broad daylight, if each summer, for example, every worm, bug, frog, salamander, and other living animal living its life close to home suffocated, those responsible would be immediately identified and called to task. Deborah Kramer highlights two difficult aspects of our relationship to the ocean: our inability to see what's happening in the ocean and the difficulty to assess responsibility. As an architect, I see that these problems, visibility and responsibility, begin close to home in our own backyards. So some of our work as architects today is to develop new ways to make the relationship of our cities to the broader environment more visible. For example, I do a lot of work with highway infrastructure. This slide shows water catchment areas of the I-93 highway in Boston. Seen through the perspective of water, highways are big collection surfaces that also add contaminants from runoff. Below ground is a network of pipes that transport this contaminated water to rivers, harbors, and the ocean. One problem with this is that all contaminants from the highway or the rail yard drain directly to the ocean. The other problem is that almost no one sees it. The ocean's tides pull the contamination away from the city, but they accrue in the ocean. Only the subtle hint of steel pipes communicates this linkage. Some of our efforts now has focused on daylighting such infrastructure to make it more legible and actionable. This is commonly called green infrastructure, where contaminated water is rerouted into planted landscapes that evaporate much of the water and filter some of the contaminants. Such landscapes can be designed as parks, circulation, and habitat spaces in the city. Another important aspect is simply the ability to see where the water comes from and where it goes, helping the community to understand their own environment. However, from such solutions, new problems and challenges also emerge. For example, rerouting drain leaders into parks brings trash and debris. Cities have long used the ocean as a convenient place to quietly dispose of such things, simply because the ocean hides these so nasty sights and odors from us. But collecting these in public landscapes means that we, one, have to be okay with this visibility, and two, we have to take the responsibility of cleaning it up. So with solutions, we need to change perception that having trash in the park might actually be a sign of care and not a sign of neglect. One solution we've developed is simple signage and graphics that help to explain the workings of the landscape. In Boston, we have one of the great historic examples of daylit green infrastructure, the Emerald Necklace, designed by Frederick Law Olmsted, landscape architect of Central Park in New York City, and built in the 1880s. Unlike the earlier Manhattan example, where rivers were eliminated by the construction of the city, Olmsted designed a river to be infrastructure for the city. Despite its naturalistic appearance, the new riverway was actually an engineered landscape to support transportation for walking and bicycling, habitat and recreation, and to drain the city of floodwaters. The designed river was integrated into the fabric of the city, such that simple participation in the everyday life of the city, like going for a walk, made the city's infrastructure more legible. However, more recently, newer infrastructure developments like federal highway initiatives in the 1950s and 60s ignored these concepts of integration and imposed new infrastructure over these landscapes. So now the same issues of direct injection of contaminants into the riverway exist here too, which has altered water chemistry and caused local algae and duckweed blooms. Here we again are proposing to reroute and daylight these water discharges to restore original principles of the Emerald Necklace. So while the landscape today hides the flow of water, we will construct new riparian zones that reveal the flows of water and re-engage the water with the beneficial natural processes of the landscape. Referring back to Deborah Kramer's quote about visibility and responsibility, as cities have grown ever more dense with systems, the allocation of responsibility has grown equally complex. Highway departments are responsible for highways, park departments for parks, water and sewer authorities for drainage, yet water flows across all these departments and jurisdictions. We also need to determine and allocate responsibility for the health of the water. This diagram, for example, shows the different jurisdictions and the complexity that rainfall passes through on the way to the river. You can see that the responsibility for the water is so complex as to often be unclear. So some of our effort now is to disentangle these systems and create clearly separated water management infrastructures so responsibility and maintenance is clear. The other negative impact of the 1950s highway on the Muddy River here in Boston was the culverting of the mouth of the river. This cut off the relationship between the Muddy River and the Charles River. Originally, residents could stand on this bridge and see the relationship of one river to the other. But the 1950s roadway construction broke and obscured that relationship. Today it is hard to even detect the confluence of these two rivers. The same bridge, which once positioned people to see the confluence of two rivers, is now the location where the Muddy River just seems to mysteriously stop. Our current project will reconfigure roadways and daylight the confluence of these river systems to restore the connection. In their aggregate, the modern infrastructural impacts on the Muddy River has changed the character of the Muddy River from this to this. For people in this neighborhood, this is what their local river now looks like. And most neighbors we speak to, even those that have lived here for 50 years, don't know the history of this river or how it became what it is. They ask questions like, where does this go? Or where does this come from? Which way does it flow? On one hand, that is a negative thing. Yet on the other hand, normally this contaminant stream would be simply hidden underground in a pipe, and the contents of this pipe would be quietly dumping into the ocean, out of sight and out of mind. contributing to the dead zones that Deborah Kramer referred to. So the simple fact that this man-made river remains partly daylit allows a community to see what is happening and demand responsibility. In fact, in this photo, the river surface is being cleaned because the community called for it to be cleaned. As an architect, I focus on how our built context shapes our relationship to the environment. I'm excited to be working with this team to develop ways of breaking through perceptual barriers between people and the environment, and I'm happy to pass this back to Keith.
Thanks, Dan. Let me just. Great. Do you see that?
Yep.
Great. So thanks, Dan, and hi again. As a conservation wildlife photographer, I've been fortunate to travel around the world on assignments, discovering many common threads from these remote atolls to urban cities. But wildlife knows no boundaries. The local experience is the most captivating, and I try to bring that perspective through my photography to a global audience. This image is of a juvenile magnificent frigate bird in Mexico, breaking the barriers between land and sea. Within the Turtle Islands, within the Turtle Islands, or on the border between Malaysia and the Philippines, endangered green sea turtles spend decades exploring the open ocean before returning to the beaches where they were born. Sea turtles are dependent upon unobstructed habitat to lay their eggs for future generations. Each year off the coast of South Africa, enormous schools of sardines form one of the world's largest animal migrations in which predators, including people, depend on for food and survival. But I am from the Boston area and grew up diving along the coast of New England, photographing similar marine life just beyond our shores. But photographically, New England's waters are a challenge. The seas are rough, the water is cold, and the visibility is difficult. But over the last few years, I, along with this team, have collaborated with the town of Plymouth to share a story of the alewife river herring that have silently been moving back and forth for thousands of years between the ocean and the streams of New England during its annual spawning event. One of the challenges for the herring is that urban rivers have been blocked by dams or other obstructions, preventing these fish from reaching final spawning grounds. But the town of Plymouth is a leader in restoring its streams and adding fish ladders like this one that has successfully enabled the herring a path forward. While most of us view the herring from land, my photography is a window into the underwater world. From a fish-eye's perspective, I've gained a new appreciation for the power of these fish to swim against the odds, a journey that almost seems impossible. And at the most extreme juncture where the river is flowing fastest, the herring unbelievably continue to accelerate forward. And with one last burst of speed, the herring swim beyond the fish ladder into calm water. Our team is now, like the herring, embarking on a new journey at the intersection of art, science, and technology to create large-scale immersive public art exhibitions and visual experiences to spark imagination, to inspire conservation, and to build local stewardship. So come join us for our public art exhibition for the Plymouth 400 celebration that will now be scheduled in October 2020. Thanks, and I'll send it back to Sara.
Great, thank you so much, Keith, especially those beautiful pictures. So now I would like Finn Payne to come on, and he will be doing our next set of questions, some polls.
Yeah, so we're gonna open this next poll up for everybody, for you guys to answer. So this poll is, to what extent do you think people are connected to other living things? So go ahead and put your answers in. And yeah, it looks like almost everybody answered 7, which is exactly what we want. So now we're going to move on to some results that we've found. If we could put that up on the screen. So you've probably been wondering what the point of all these questions were. So we're going to go ahead and show you what we can actually do with these questions that we ask. A little backstory: we conducted a study about a river, asking questions much like the ones we've been asking today. This figure on screen right now is a principal component analysis. So we asked a large amount of questions in which the participants had to answer after reading a short narrative about a degraded river. And this type of analysis groups these questions together, and in this case came out with two measures which we concluded were ecological investment and ecological connectedness. The principal component analysis pretty much plots all these responses on a matrix, and these measures come from the clusters of questions that were grouped closely together. In this case, there were two groups that were grouped closely together. And what we can get from that is, so for example, at the bottom there, we have new laws to protect, which asked, to what extent would you be in favor of new laws to protect the degraded river? So if a person were to answer that they were very for having these new laws to protect a river, they would also be very likely to say that they were in favor of community-based initiative projects to also help that river, because they're grouped into the same measure. So that's just one type of analysis that we can do, and I will pass it to Harley to show you guys another type of thing we can do.
Thanks, Finn. So by asking other research participants questions like we asked you earlier, and regarding the measures that Finn just described, we are able to then look at the relationships between them. So this figure shows a strong positive relationship between ecological connectedness and environmental stewardship. And specifically, the more connected that people feel to nature, the more they said that an urban waterway was worth restoring. So this data gives us hope that encouraging personal connections with local ecosystems may in turn encourage more environmental stewardship in the future. And now I'm just going to hand it off to John to finish this up.
Thank you, Harley and Finn. Just to sort of wrap things up before we open it up for questions, I just kind of want to pull together what we've been trying to express to you. So the interaction between people and oceans and people and coastlines is complicated, extraordinarily complicated. And what we do in the CLEAR Lab is we try to approach it from a number of different perspectives. So we have the cognitive perspective, trying to understand how people think about these relationships and use that knowledge to help improve stewardship. We have climate science, like Brian was talking about, trying to understand the actual natural relationships themselves. Science communication, like Francis was talking about, how we take this marine science and convey it to people in a way that makes sense and helps them feel connected and empowered. Architecture, like Dan was talking about, where people are building and manipulating human spaces in a way that emphasizes and daylights the natural environment. And finally, Keith's amazing photographic work, which really brings home in a very visceral way what life in the ocean is like, things that we otherwise would never have a chance to see. And we see all of these as interconnected, and the idea that a problem of this complexity of understanding coastlines and preserving coastlines needs a complex solution, needs a multifaceted approach to understand it. And one thing that I want to leave you with is we don't claim that the perspectives that we've taken exhaust all the possibilities. We know there are other perspectives that would be important to add to our approach. And this is one thing we'd love to talk with you about during the question session. What are we missing? What other kinds of perspectives could help us in this work? And the last thing I want to leave you with is looking forward, our lab vision. So the vision of the CLEAR lab, our goals are to use cutting edge techniques from cognitive science to investigate people's knowledge and understanding of their local environments, and to explore how applied visual arts can be mobilized to enhance knowledge and understanding, and to increase environmental stewardship by fostering feelings of ecological connectedness. To achieve these goals, CLEAR Lab brings together academics from diverse disciplines, members of the arts community, and the general public to collaborate in developing and enacting innovative programs at the intersection of art, science, and environmentalism. Thank you so much.
Thank you so much, everyone, and thank you, John. So now we are going to go into the portion of the night where we ask all these amazing questions that people have put into the Q&A. If you have any other questions, you can use that Q&A button on Zoom to ask questions. So now I'd like everyone to turn their cameras on and we will go through some of these. So I will ask the first part of this question because it's a little bit long, but how can urban dwellers be actively engaged in environmental activities as part of their everyday lives?
Well, I can say, I mean, I think that that's something I take to heart in terms of being the urban environment and thinking about. It's something we reflect on a lot is, you know, how do we make an environment sort of transparent and legible and, you know, clear, not to use our lab name too literally, but that, you know, just going, I often think about it, how many things as architects, maybe it's because people decided something was ugly or they, you know, a lot of times don't even want to think about it. You don't want to be kind of confronted with your own negative outputs, your trash or your sewerage or the ugliness of the mess inside your walls. So we cover the walls with drywall and hide all the utilities inside, or we take all those sewage pipes or we bury them underground. And all of a sudden you don't even see your own footprint. So I think a lot of that is kind of reflecting on our habits about how we make our environment and kind of questioning what things have we been intentionally hiding from ourselves for decades and bringing those back out to the forefront. So I think that that's something we can assess across a lot of our ways we build and ways we live.
Just let me jump in for a second. I think that's just about the question here. So we're really, what we've done, we sort of in a preliminary way demonstrated that there's a linkage between people's feelings of connectedness and their environmental behaviors. And now I think the challenge is really to find ways to increase or enhance that feeling of connectedness. The one way that we are most actively pursuing right now is working on these large, attention-grabbing, immersive public art displays, like Keith showed you at the end of his talk, where you have herring, you know, 30-foot herring swimming across the side of a barn. But I think there are lots and lots of other ways that we can think about to increase people's feelings of connectedness. The kind of conversation that we hope to continue having.
And I'd like to add to that too as well, is that in terms of science communication engagement is we try to use fun things and things that relate to people and meet their own perspective. So VR goggles for younger generations. These talks are great for everybody. Public engagement, like the public forums, are great as well. But at the same time, we always bring up the message of these environmental activities are as much as you can do. We're not, a lot of times we're not asking for big global things of less, take all the garbage out of the ocean. It's just small little ideas that you can instill and become part of your behavior and part of your pattern. And that's the way of how you can slowly, actively engage with environmental activities.
Yeah, so this question also has to do with messaging and wording and how we go about talking about these issues. So this question is, what about if we use messaging that we seem to use for coronavirus? The messaging that we use is to keep social distancing, keep wearing face masks. But for the ocean, could we say that if it would be the climate and ocean doesn't quite care about you, but if you harm the ocean, we need to do these certain things. So maybe just a question about messaging and how we do science communication in this field.
I think John's going to know the answer to this far better than I do, but I think that's exactly right. Climate change doesn't care whether you believe in it or not. It's still going to impact you. The challenge and the contrast is that right now, coronavirus is affecting people across the globe more or less at the same time. I mean, the peaks are happening at different times, and the severity is happening at different times, and the vulnerability is different. But it's something that is an experience that I think we're all sharing. One of the challenges of climate change is that it happens asynchronously. One area may be hammered by it, and for a brief period of time, people understand that it's related to climate, but then they forget about it when it's hitting somebody else halfway around the world. And so the only way to put that together in this large picture is to have communication, to have empathy, to share those experiences, to really understand that we as a planet have this shared experience, but it just plays out in our very local environments. And John, I don't know if you or Finn want to add to that as well.
What I was going to say is I think we have to be a little careful about messaging because I think it can cut both ways. So if you present information in a way that sort of might be intuitively palatable to people, might kind of fit with their informal understandings, one thing that happens is it might be easy for them to take up and remember, but it might also reinforce the sorts of misconceptions that people might already have. So for example, if we packaged information in sort of an exceptionalist way, it might reinforce people's understanding of this base or belief that the relationship between people and their environment is kind of grossly asymmetrical. So I think we have to balance the idea of making information intuitively available to people, but also not reinforcing the kinds of misconceptions that people might come to the information environment with.
Yeah, I might also add, one of the things I think we're trying to do is to illuminate environments and habitats that people may walk by frequently, but not really notice in some ways. And so by creating people a sense of compassion by either understanding where they are and where science is going, or by understanding the nature that they see and they never saw before, or by understanding how the city and their relationship to the city and the environment are all connected. And I think that one of the things we're trying to build is that human connection to these animals and environment to further build people to have a greater sense of care and compassion at a larger scale.
Great. So we have a lot of questions coming in about science communication for schools in Massachusetts, for middle schoolers, or just for K-12 messaging. Do you ever work with these groups, or are there different messages or different ways to communicate to this age group?
Francis, do you want to tell them about a little bit more about the work with Girls Inc.?
Sure, yeah. So we work with the Girls Inc. of Lynn. There's a group within Girls Inc. called Beach Sisters where we spent a semester with them dealing with an issue or a problem that they're interested in doing. So a few years ago, they're interested in single-use plastic bags. So we went in and we looked at, well, what does plastic bag do to the environment in Lynn? Who will use garbage, single-use plastic bags more than anyone else? Does this affect them? Does it affect the community if plastic bags don't exist anymore? And so they've learned and created a campaign and actually went out and lobbied for a ban in single-use plastic bag in Lynn and was quite successful. And so we do these programs with after-school students as well. We do it with K-12 school as well. Brian and I worked with Stage School in Foxborough, and we worked with a second grader class. And we did these virtual tours with them. We learned about the environments. We had visiting scientists over Zoom, talking to them about science. And this is a much larger program, or this is a small part of a larger program that actually the Marine Science Center at Northeastern, there's an outreach program out there. And we're part of that program as well, where they do go out and reach out to a lot of K-12 schools as well. So if anyone's interested in having marine scientists come and visit their K-12 class or come in through Zoom or Skype in the classroom, you're more than welcome to contact Brian and I, or even reach out to the Marine Science Center outreach program at Northeastern.
Can I just add on to that, that very selfishly, one of the coolest things about working with K-12 students is the input of really fresh ideas that those of us who've been doing this for a long time just haven't thought about. I mean, I truly believe that the only way we're going to find these solutions is to really hear from voices that we have not heard from before. I mean, the definition of insanity is doing the same thing over and over again and expecting a different result. And so if we only hear the same voices, we're going to be stuck in the same place. And I'm always amazed at how creative younger people are in finding solutions once we work with them collaboratively on some of these challenges like Francis was talking about.
Great, thank you. So we have a lot of questions coming in for Keith. The first question is, how did you get the photograph of the muddy river? And the second question is, what's the most dangerous situation you found yourself in while documenting nature?
Well, you know, for the muddy river, I think that the challenge of Boston and the area here, I think, has been learning to work in low visibility areas and to position light and cameras and angles. And to really work with a team like this, we're able to know where to go, what time to go to get those images. So I feel really fortunate that, you know, we've often as a group gone out to locations and scouted and picked the right time and sort of tried to pick our moments. And that's been very helpful. But I will say that it's been a lifetime of learning how to work in very low visibility to no visibility conditions and to make something that really comes out special in that way. And I should say that I spend a lot of time working on this. I mean, people think I just put a camera in and take a picture, but I might spend days or weeks or certainly hours working on an image. And in terms of danger, you know, it's really more about going for the animal and trying to get in position for that. You know, life is full of risks in lots of ways, but the reality of this is that I try to go to capture images of where the animals are, and I will go to, you know, where they are in the world, I guess, to do it. It's unfortunate that sometimes they like stronger current, and, you know, I can only swim so fast, but I try my best to keep up and to do things. And so it's a joy, the image making.
Can I also tell a story that Keith has told me, that he has photographed a great white shark coming up to him last year, and he can elaborate on that danger story.
Well, I'll just very quickly say that what makes the Northeast coast, and in this instance, I was in Stellwagen Bank National Marine Sanctuary, which is just 25 nautical miles off the coast of Boston, is that there are many unexpected, you know, iconic animals. And in this instance, I was looking for to photograph some animals, and there's always an element of surprise. And a great white shark, a large 16-foot great white shark, did swim within an arm's length away from me. But, you know, I feel fortunate that I've had a lot of experience photographing sharks, and this wasn't my first time in the water with them. And so was comfortable. But, I would never go knowingly in the water with a great white shark. They're to be admired and understood from a distance, not to be diving with. They could be quite dangerous. Anyway, our project doesn't usually involve great white sharks.
Well, thank you for answering those questions. Our next question is for Dan. This question is, are there any environmental benefits to building underground highways so that they don't accumulate runoff?
Well, that's an interesting question. From the specific perspective of runoff, and this is actually what's so hard about it, right? I mean, water infiltrates in the ground. So if you submerge a highway, it's still what we call an impermeable barrier to groundwater exchange. So a lot of times, we don't sort of think about those kinds of movements or aquifers underground, but in fact, even any kind of submerged tunnel will prevent that kind of water exchange. I think the other thing that's always important, and I think it's something for us that our group talks a lot about, is like when you put ecology in the context of an urban environment, what we sometimes refer to as urban ecology, it gets like really complicated. And so you always almost have to weigh pros and cons. So for example, Boston, we know the Big Dig was a huge enterprise to submerge a highway infrastructure, which has the positive that it created all sorts of new parkland. It created new urban connections. And, those are maybe positives seen through a certain light. On the other hand, submerging a tunnel near the waterfront that, is prone to sea level rise and prospective flooding means, you're going to spend a lot of petroleum to keep that tunnel dry, running all your pumps. You got to ventilate a tunnel to get the fresh air in and out of it. You got to perpetually light a tunnel. So, you pick up a park in that deal, and you pick up urban connections in that deal, but you also pick up a great deal of like burnt petroleum in our current context to power the tunnel. Or it might be a little more prone to flooding in a surge event. So those are like, I think, the really interesting, complex issues of urban ecology today, is to always be mindful that even with anything that seems positive, there's often a negative, and you have to kind of counterbalance and assess those full impacts.
Great, thank you. This is a question for John. Someone has heard you use the term human exceptionalism, and they would like you to define that further for us.
Sure. So as I was trying to point out in my talk, apparently unsuccessfully, my apologies, human exceptionalism is the idea that people are sort of separate from and disconnected from and exempt from the laws of biology and ecology. So, for example, the idea that humans are responsible for climate change, but are unlikely to be affected by climate change, is sort of an exceptionalist idea. And what we've shown in our work is that that belief, especially when applied to understanding biology and ecology, is associated with a number of sort of attitudes and other kinds of beliefs that tend to discourage environmental stewardship.
Great, thank you so much. So this question says, in the beginning it was mentioned that vulnerability to climate change involves more than just the position closest to the coastline. Would you mind going further into specific demographics and factors that makes a person vulnerable?
Yeah, so I can kind of speak to this one a little bit, and I think this has to do with a little bit about what Brian talked about, which is kind of a new emerging discussion, which is environmental justice. And that talks about how a lot of marginalized communities, so communities of color, lower income communities, are more impacted by things like climate change, things like pollution, water pollution, access to all of these clean water and food, and that goes along with climate change because of the way that society has structured. So if you look at, for example, a map of Massachusetts and what we consider a relatively blue state, relatively liberal state, if you transpose a map of landfills and hazardous waste sites over communities of color, you can see that those overlap significantly, and that's not a coincidence. And that same thing happens in terms of climate change, with people being lacking access to the resources that they need to kind of combat this this problem that we have. I don't know if you want to add more to that, Brian.
Yeah, I think you covered it really well, Harley. I mean, I think a lot of how we see geographic racism, for example, is the history of how the city of Boston was built over the last couple hundred years. And so our partners at Museum of Science, led by David Sittenfelder, showed that if you look at urban heat island effects, places like Roxbury are often the hardest hit because they don't have as much vegetation. And so there hasn't been infrastructure invested in those locations. And the other thing is that when we build things like seawalls to try to protect communities, typically those are wealthy communities, and it doesn't get rid of the problem, it just moves it downstream, down the coast, until where? Until you hit a section of coastline where the community can't afford to build the seawall. And so the most economically disadvantaged people are the ones that end up feeling the brunt of the problem because the richer communities have shunted it their way.
Great, and you briefly mentioned urban heat islands and the urban heat island effect. We do have a couple questions about that. One of them is, how have urban heat islands affected urban biodiversity? And Adam H13 asked that question.
Do you want me to try that one? Adam, that is an awesome question. And frankly, I don't know. There's a little bit known. I mean, we know that it, oftentimes we can see like heat tolerant plants in areas with the hottest temperatures. We know that there are, in some places, we see trees blooming earlier in the spring in urban heat island effects, which if they're blooming too soon and the pollinators aren't there, that means they don't get pollinated. But honestly, it's a really open area of research right now. The relationship between urban structure, the kinds of things that Dan's group does, and how that affects biodiversity. And then the flip side is how that biodiversity, and especially things like vegetation cover, then drive the urban heat island effect. And so it's that feedback loop. So
but to add to that, I mean, taking one step back, like what are the causes of, or what are some of the primary drivers of urban heat island effect are things like, you know, buildings and roadways, paving, you know, hard surfaces that have no absorptive quality or evaporative quality. And, you know, let's just put it this way, it doesn't take a whole lot of study or even the efforts of Brian to tell us, when you go and pave the earth with asphalt, which is like a low-grade petroleum residual, you're not going to have a whole lot of biodiversity inhabiting that asphalt surface. It effectively, and that's why I think things like green infrastructure systems are so interesting. Like, I mean, one of the big efforts right now to combat heat island effect in urban environments in this area in particular are things like the planting of deciduous trees, right? And again, when you put that in the context, because of why deciduous is so important in the context of New England, is in many ways, for when you put it in an energy model, you want that heat in the winter to reduce your petroleum consumption, but you actually don't want that heat in the summer when it ups all the energy consumption. So actually the big tree planting initiatives that have been driven in the Boston metropolitan area have largely been driven out of an energy consumption, like energy reduction model. So that's, I think, when you, I think, you know, Brian said it really nicely before about the kind of nature human coupled systems, is you almost always, and I think it even ties to John's point about human exceptionalism, is to not separate the kind of human factors from the natural factors anymore, but really understand how sort of decisions made in pursuit of one get counterbalanced by the other.
And Adam, that is such a good question to ask. And I would want to draw to some of the photographs that Keith has shown in the presentation. And hopefully after this webinar, you can see the replay on Facebook. And one of the two images that are so striking is the image of the coastal fishing town in Massachusetts. And then he goes right into the Manhattan Island. And you can see very strikingly that there is a lot of biodiversity going on in a place that has less urban structures, maybe less urban heat effects. And then you go right into Manhattan, where nature is actually being constructed into the city, which is really interesting. That leads back to what Dan was talking about of, well, how do you actually integrate nature back into something that's already so urbanized already? So, and those two images are just so striking, and hopefully you get a chance to go back and look at them.
So this concept has been touched through all of your presentations, but this question asks, what is the relationship between where someone lives and their sense of ecological connectedness and or their belief that there is a reciprocal relationship between people and their environment?
It sounds like a cognitive psychology question.
I'll take a crack at it. That's a really good question, and we don't know enough about it. Some of my work and work I've done with colleagues suggests that people who live in a more ecologically rich environment may see the biological world as more of a reciprocal connection between species rather than sort of single directional connections. So we've done work showing that children growing up in rural Massachusetts are sort of more ecologically oriented than children growing up in suburban or urban Massachusetts, even controlling for a number of other factors. But it's interestingly, it's not sort of, you're not doomed by your immediate environment, because we also find that this is children aged K through 6th grade, so 5 through 10, basically. Children who engage in more sort of unsupervised, unstructured exploration of the natural world also tend to view things in a more sort of reciprocal, ecologically connected way, independent of the population density of the town. So I think there are sort of demographic factors that predict people's understanding and people's kind of ideas of connectedness, but also the sorts of individual opportunities and interests that people have and the things they seek out can also impact that. There's also, I think, a lot of cultural variation. So we've done some work with Native American groups in northern Wisconsin and in Guatemala, and we find that ideas about humans being part of an ecosystem rather than separate from an ecosystem are very predominant in those groups. So there's a kind of a cultural belief element as well, but that's a great question.
Great, thank you. So I think we have time for one more question before we say goodbye. And that question is for all of you. What would be considered a success for this enterprise?
I can take a first crack at that. I mean, I think our overarching goal or our mission is to try to take the best of what we do in academic environments and work with partners outside of academia to help solve problems. I mean, I think it's, how do we effectively integrate with people like the audience to find solutions. I mean, I think really, I don't know, I think I speak for the group where, you know, we're less driven by getting research papers out than we are trying to actually enact change. At least to me, that would be the success, the end goal of this. See what others think.
Yeah, I mean, I can jump in too. I mean, I think there are lots of successes. I think one thing that has been really an eye-opening experience for us is this interdisciplinary nature of things. And I think as we look at education and we look at things aren't so one-dimensional, and I think even providing students these multi-disciplinary experiences. And I would add that I think if the public, sees some of these, whether it's exhibits or these lectures or whatnot, and then re-looks at their environment that they're in differently, then I think that would be a measure of success if change starts to happen one person at a time. And I think that's why we're trying to have these sort of these presentations and eye-catching exhibitions and sort of interviewing and communicating with lots of people through surveys and stuff to understand and to then react to and sort of to position ourselves in innovative ways.
I tend to kind of feel like having more groups like these would be great, would be a more interdisciplinary kind of subject, as you know, Brian and I live in these marine biology bubbles, but just coming out of it and just knowing that other professions are really also interested in these kind of ideas too, and their perspective is tremendous. And things that we've learned in the last, you know, year and a half is exceptional. But having more of these groups and working together, either, you know, in university institute or even better in, you know, community groups would be fantastic.
Just to echo what Francis said, I think one thing that's really exciting to me is the interdisciplinary nature of what we're doing. And it's not easy, right? So sometimes we'll be in a meeting and Dan will say something and I'll think, what the hell did you just say? What does that even mean? But taking the time and the effort to really see a problem from a very different perspective and realize, oh my God, it's the same problem from a different perspective, has been incredibly valuable for me as a scientist. The other piece that I think right now we're missing, and we're just starting to work on, is establishing real partnerships with community organizations around Northeastern and Boston, organizations that represent people who live adjacent to the Muddy River, which is sort of a central concern of our project at this point. So I think partnering with the community and putting ourselves in a position where we can give back to the community what we're learning about how these issues intersect with each other is a really important part of this.
Yeah, I can only really echo what others have said, but I mean, I think in some ways, I guess as the architect, I sometimes feel like the sort of like odd evil villain in some of these conversations, simply because so much of what we're all talking about is quite literally of our own making, right? Sort of we've built these in environments, and we built them with certain aspirations and goals, and often the consequences that we're reaping now are a result of things that we, just because we didn't anticipate or didn't consider or didn't design for or didn't prioritize those kind of consequences. And those consequences are things like, you know, what's happening in the ocean, or what's happening to our ecosystems, or how have we created an environment that people don't even understand their impact of. So all these disciplines really play a critical role for, like, me personally, and in many ways thinking about and raising all the questions of, like, what are all the things we don't think about as architects. It's very rare that someone talks about a building, and as they're talking about the building, talks about its relationship to a fish, or how people in 100 years might understand or misunderstand their building. So issues of psychology, issues of marine biology just are clearly impacted by architecture. But I can't say, and maybe John is another form of weird exceptionalism, like architectural exceptionalism, like I can't say that we've honestly thought about how architecture is impacted by those things. And in one way, that's really like depressing and sad. On the other hand, it's, as researchers, and maybe for young people who are on this, it's incredibly exciting, because it means there's so much we have to learn and figure out. So there's a lot of kind of new territory of discovery embedded in all those problems.
I think something really cool that we will probably end up doing through this lab is that it's one thing to just understand and, you know, write papers about how people view the environment and how they're impacted by the environment. But we're actually going to be able to apply what we've learned. Like, you know, we have photographers and architects and marine biologists. So we can take what we've learned, that's, you know, actual data, actual statistics, and apply that to the real world. You know, are they impacted by these giant installations of fish on a wall on this giant building? So yeah, I think that'll be very interesting to see in the future.
All right, well, thank you all so much. We have a lot of unanswered questions, but we are all out of time for this program. I just want to thank my panelists again, have them wave goodbye and turn their cameras off. Thank you all so much. I look forward to all the things that are going to be coming out of this exciting new research collaboration, especially being able to connect art and science and emotion to our oceans. So on the screen, you can follow them on Twitter at clear_NU lab or visit their website to learn more about the project. And to check out more programs at the Museum of Science, you can visit the website mos.org/mosathome. You can also follow us on social media. And Twitter, we're at Museum of Science. If you enjoyed today's presentation, please visit www.mos.org/Science Matters to support MOS at Home. That's www.mos.org/Science Matters. So thank you so much, everyone. Enjoy the rest of your night, and we hope that we'll see you for our next upcoming community conversation programs. Thank you all.